Taking public transport is great for energy saving. However, for some engineers, this wasn't quite enough, and they've designed a bus that's even more environmentally friendly. The rechargeable bus is pulling up at stops all over the city, so let's hop on and find out more.
The first electrical trolley bus was invented in Germany in 1882. Over 100 years later, a technological revolution is aimed to rejuvenate the century-old service. A new form of electric bus has been developed by collaboration between Sinotech Automobile Technologies and Shanghai Away Technology Development Corporation. This electric bus has gotten rid of the troublesome overhead power lines and saves 40% of the electricity compared to an electrical trolley bus. It sounds good, but how does it work? Without the power lines, what else can drive an electric bus? The answer is onboard ultracapacitors. You might be familiar with energy storage devices such as batteries and capacitors. Batteries are good for storing enormous energy, and capacitors are capable of quickly capturing and releasing energy. The ultracapacitor is a unique combination of high energy and high power. It makes it possible to provide the power the electric bus needs. It only takes onboard ultracapacitors 5 minutes to be fully charged. However, their power can only run the bus for 3 miles. That's equivalent to 20 city blocks. Therefore, it is essential to look for places halfway to recharge. The most feasible way is to change the simple bus stops into an electrical charging station. Whenever the bus stops at the station to pick up passengers, the driver can control the collector on top of the bus to rise and touch the overhead electric charging device. The electricity draws will recharge the ultracapacitors. The ultracapacitor bus is also equipped with a backup battery. Electricity stored in the batteries can allow the bus to travel for 50 miles. The combination of ultracapacitors and batteries allows the bus to serve in both long and short distance bus routes. Besides recharging at bus stations, the electric bus has one more way to generate electric power. That is to recover energy when braking. When you hit the brake, the vehicle has to release its momentum in order to slow down or stop rotating wheels. Traditional mechanical braking systems use friction and generate useless heat. Yet with the electric vehicle, the electric motor can act as a generator, turning the kinetic energy into electricity to feed back into the ultracapacitors. As we mentioned before, the ultracapacitor is capable of quickly charging. This makes it the ideal equipment for drawing electricity. The operating control system is another highlight of this new bus. In fact, the computer helps the driver in many ways. When the driver is ready to work, he swipes a card to activate the system. While driving, the driver can be informed of useful information on board the color LCD screen, such as speed, total distance, electricity consumption, and running time. The bus is also equipped with an onboard global positioning system. The position of the bus can be sent to the control center via a satellite. Combined with the geographic information system, the dispatcher can learn about the current position and speed of the bus on an e-map. This enables the dispatcher to better arrange bus services and solve accident problems through messages and phone calls. Moreover, with sensors installed underneath the steps, the computer can estimate the volume of passengers with 90% accuracy. This kind of information is also sent to electronic bus stops. Riders at the bus stops can check the real-time display to see when the next bus is coming and how crowded it is. Currently, the transportation sector is the second largest source of CO2 emissions in the United States. The EPA estimates that an average municipal bus consumes 9,500 gallons of diesel per year and emits an average of 100 tons of carbon dioxide. The ultracapacitor bus consumes only 2 kilowatt-hours of electricity per mile of operation, which is equivalent to 25 cents in electric cost. For an average municipal bus, that translates to over $15,000 in annual fuel cost savings. There are plans underway to supply the power of the ultracapacitor bus by rooftop solar panels. Using the sun's inexhaustible power, the ultracapacitor bus will be able to achieve the dream of carbon-neutral transportation.